Picture this. It's a perfectly normal, beautiful spring day in the Northern Hemisphere 66 million years ago. The air is warm, you've got dinosaurs hunting in the ferns, early birds are just fluttering overhead. But then, bam! Without any warning at all, a blinding flash of light literally tears across the sky. The ground violently heaves beneath your feet, and within moments, absolute suffocating darkness just swallows the world whole. Just like that, in a split second, an era that lasted 17 million years is abruptly, violently canceled.
It really is the ultimate prehistoric cold case, isn't it? I mean, for decades, scientists looked at the fossil record and asked one simple, incredibly baffling question. What exactly wiped out the dinosaurs along with 75% of all living species on Earth in what is basically a geological blink of an eye? Today, we're playing detective. We're going to piece together this massive mass extinction event, relying totally on geological clues, hard data, and the fierce scientific debates that really define this whole mystery. We're looking at a story of apocalyptic destruction, hidden evidence, and an absolutely incredible evolutionary loophole.
Section 1. The Spring of Extinction. Okay, so the sheer incomprehensible scale of the destruction here is just staggering. We're talking about a space rock estimated to be 10 to 15 kilometers in diameter. That is taller than Mount Everest, and it slammed right into the shallow tropical seas of what is now the Yucatan Peninsula in Mexico. The kinetic energy released when it hit? 100 million megatons of TNT. To put that insane number into perspective, that is over 1 billion times the energy of the atomic bombs dropped on Hiroshima and Nagasaki. 1 billion!
Now, crucially, it wasn't just the initial fiery blast that killed everything off. It was a rapid, cascading chain of absolute catastrophes. First, the impact triggers these immediate mega tsunamis, waves over 100 meters tall. Second, because it happened to hit a shallow, sulfur-rich seabed, massive amounts of vaporized sulfur were injected straight up into the stratosphere, which rapidly leads us to step 3, a global winter, where soot and aerosols blocked out the sun for years, totally halting photosynthesis. And that, ultimately, brings us to step 4, a complete and total ecosystem collapse.
To really grasp this, look at a fossil site in North Dakota called Tanis. Scientists found a literal snapshot of this mass death happening within hours of the strike. Co-author David Burnham described the fossilized fish found there, and this is wild. He said, "They're not crushed. It's like an avalanche that collapses almost like a liquid, then sets like concrete." The sheer violence of the water movements, triggered by seismic shocks equivalent to a magnitude 11 earthquake, just buried whole ecosystems instantly.
Section 2. Clues from the Iridium.
So, flash forward to 1980. A research team led by a father-son duo, Luis and Walter Alvarez, makes a startling discovery. They find this thin, very distinct layer of clay all over the world, situated perfectly at the geological line marking the end of the dinosaurs. And inside this clay, they found unusually high levels of an element called iridium. Now here's the catch. Iridium is incredibly rare on the Earth's crust, but it is highly common in asteroids.
This microscopic layer of iridium, it was the ultimate smoking gun. It essentially proved that a massive extraterrestrial object had impacted Earth, vaporized, and dusted the entire globe with its chemical fingerprint. It's a beautifully elegant hypothesis, but it left the scientific community with one massive glaring problem. If an asteroid that big hit the Earth, where on Earth was the crater?
Section 3. Discovering the Chicxulub Crater.
The timeline of actually finding this crater unfolded over decades. Back in 1988, a geophysicist named Glenn Penfield was looking for oil down in the Gulf of Mexico, and he noticed this massive underwater gravity anomaly, a perfect 180-kilometer-wide bullseye, but it was largely ignored at the time. It actually wasn't until 1990 that scientists connected the dots using tektites, which are these tiny beads of glass formed only in the extreme heat of an impact, linking that global iridium layer straight to this hidden crater. Fast forward again to 2016, and an international deep drilling project finally pierced the peak ring of the crater itself.
And the evidence they pulled from that 2016 drilling was just staggering. The core samples revealed shocked deep crust granite, proving the solid rock literally behaved like a fluid upon impact. And crucially, they found a near-complete absence of gypsum in the crater. This confirmed the absolute worst-case scenario. All that sulfur-rich ocean floor rock had been instantly vaporized into the sky, cementing that catastrophic global winter effect we talked about. They even found massive sand deposits dumped by the returning mega tsunami. So case closed, right? Well, not quite.
Section 4. The Volcanic Debate.
You see, while the asteroid hypothesis has overwhelming support, a fierce scientific debate emerged pointing to a completely different suspect: On one side of the ring, you have the sudden, catastrophic asteroid impact. On the other side, you have the Deccan Traps. This was an area in India experiencing gradual, unimaginably massive volcanic lava flows around the exact same geological time frame.
Comparing their environmental effects shows exactly why scientists were so divided. The asteroid impact produced soot, dust, and immediate global cooling. But those volcanic eruptions, they produce massive sulfur dioxide aerosols, long-term CO2 warming, and severe ocean acidification. Scientist Gerda Keller and her colleagues actually argued that these prolonged volcanic conditions were lethal enough all on their own to wipe out the dinosaurs, suggesting the asteroid might have just been, a coincidence or a minor contributor.
But recently, researchers from UC Berkeley proposed this fascinating unifying theory that links both events together. Check this out. The asteroid hits 66 million years ago. Then, just 50,000 to 100,000 years later, which is literally just a blink in geological time, the absolute largest phase of the Deccan eruptions occurs. The theory suggests the impact hit the Earth with the force of a magnitude 11 earthquake, sending profound seismic shockwaves straight through the planet that essentially turned up the dial on the Indian volcanoes. So, the asteroid pulled a trigger, and the resulting supervolcanoes ensured the ecosystem simply could not recover.
Section 5. Birds' Survival Secret. Now consider this profound question. How in the world did fragile, toothless birds manage to outlive their terrifying, heavily armored apex predator dinosaur relatives? When the sky went dark, temperatures absolutely plummeted, and the global food chain totally collapsed, how did fragility become an evolutionary superpower?
The answer is beautifully simple, and it all comes down to diet. While the sun was blocked out and leafy plants died off, early bird ancestors had already evolved toothless beaks perfectly adapted for a seed-based diet. So even after these massive, continent-spanning wildfires scorched the earth, nutrient-rich seeds and kernels remained safely buried under the soil. These early birds could basically eat what the giant carnivores and herbivores couldn't, allowing them to survive those harshest years and rapidly repopulate the empty planet.
And this brilliantly illustrates the ultimate irony of the extinction, doesn't it? While giant, terrifying meat-eaters were starving to death in the cold and the dark, tiny, unassuming seed-eaters found a hidden feast right there in the ashes of the old world. They inherited the earth simply because of what they were able to eat when the lights went out.
Which leaves us with one final, pretty awe-inspiring thought to take away from this explainer. The fiery extinction of the non-avian dinosaurs completely cleared the ecological stage. It allowed small mammals, our tiny burrowing ancestors, to emerge and eventually evolve into us. So ask yourself, if a single space rock hadn't hit that exact sulfur-rich spot in the ocean, triggering this highly precise apocalyptic chain of destruction, would humanity even exist today to tell the tale? Something to think about the next time you look up at the stars, or, honestly, the next time you see a bird flying by. Thanks for digging into this with me today, and as always, keep questioning the world around you.